Welcome to our webinar regarding our electrodynamic testing machines, LTM. First of all, I would like to introduce myself. My name is Christoph Belser. I'm in the sales department, responsible as product manager for these LTM testing machines. I'm here in this company since about 7 years. My background is mechanical engineering, and I'm dealing worldwide with these type of machines. That's the overview of what I want to present today. First of all, I want to present an overview about the LTM, and then I want to show you how versatile this machine is and for what testings, as an example, the machine can be used. Yeah, first of all, it's biomedical testing, then plastics testing, then metal specimen and components, electronics and electric components, automotive components, batteries and battery components, and then I want to show you one slide about what we could do with customization of test setups and the testing machine itself. Here I want to show you, first of all, an overview of the LTM types or models that we have. So first of all, there is the LTM 123, 123, and 5 and 10 is for the kilonewton range that you can operate the machine. So the 123 kilonewton machine we have in two different types. One as a tabletop model, as we call it. There a real solid table is required to give the machine a solid base. Next is the same machine type with a steel base. Then the machine stands on its own. Then we have the LTM 5 and 10, so for 5 and 10 kilonewton. You can see it as the third example. Here displayed a machine with temperature chamber. The temperature chamber can be used on all our LTM types. And on the right-hand side, you can see an example of our torsion drive machine, and this machine is available as well from 1 kilonewton with 10 Newton meters up to 10 kilonewton with 100 Newton meters. As you've seen before, the machines require a pretty small footprint. So the footprint of the machine itself, of the biggest machines, is about 800 millimeter by 800 millimeter. That's the footprint of the basic machine. The stiffness is pretty high. For instance, we took the column design and adapted the stiffness for the 10 kilonewton machine from a 25 kilonewton machine. And what you can do is you can do dynamic testing, so fatigue testing, and static testing, all in one machine type. The frame is ergonomic for installing your specimen or setting up the test. You can directly be in front or sit in front, have your T-slotted table and install your test, or you can use the specimen or grips, specimen grips that we have. The machine is all operated with a remote control. This remote control is delivered as a standard with every machine. And you can electrically adjust the crosshead, and this can be done with the remote control. You have a clamping device at the crosshead that shows with a green light that the crosshead is clamped, and it shows with a blue light that the crosshead is not clamped. And it's economical and energy efficient, as with the electromagnetic drive. There is no oil, so you have limited cooling. You only have to cool more or less the electric motor of the machine. In the next slide, I will show you how this basic working principle is set up. You have low maintenance cost, as mainly the maintenance can be done by the user or operator itself, and it's all described in the manual. And what you as well can do, you can use our test equipment on all our machines. For instance, if you would have in your lab a LTM1 and you buy a LTM10 later, you can have the LTM1 tooling for the LTM10 if the force level is okay, or vice versa, the LTM10 tooling at the LTM1. And if the tooling itself is smaller, we have all adaptive flanges, so all your testing equipment can be used on all of the machine types. What we have is a special patented drive system. So here you can see in the middle the basic working principles. You have a magnetic field with some coils around a rotor with permanent magnets, and by changing the magnetic field, the rotor in the middle is moving up and down. And what we did as a patent, our rotor is hollow, which means that we have the possibility to have our displacement measurement inside this hollow rotor as close as possible and protected from the environment inside this moving rotor. So thermal effects or tilting effects that might be occurred during the movement of the rotor will not affect your measurement, as this measurement is not influenced inside the hollow rotor. Basically, as mentioned before, the whole machine type is oil-free, so no oil is included in the machine. Some moving parts must be re-greased from time to time, but this is all, as mentioned, described in the manual and can be done by the operator itself. The bigger machines as displayed on the right-hand side, it's an example of a LTM10 with safety housing. So we have safety housings for our machines as well. Can be operated up to 100 Hertz. Smaller machine types, as the mass of the rotor is lower, can be operated even up to 120 Hertz. The smaller machine types, LTM 1, 2, and 3 for 1, 2, 3 kilonewton, has a noise level, standard noise level during operation of 46 dBA and a maximum noise level of 63. On top there is a fan installed, and this under permanent maximum loading would cause a 63 dBA noise level. The LTM 5 and 10 for 5 and 10 kilonewton has a maximum dBA of 68, but that's as well the maximum. the normal noise level is around 50 dBA for normal operation. So with this introduction of the machine itself, I want to show you some examples, or start with the examples to show you what can be done with the machine. So first of all, there's biomechanical testing. So here I show as an example spinal implants that can be tested according to certain standards, for instance, ASTM F1717. We have not just the machine and the tooling, we as well have the right software that helps you to do these tests. In the software, the test is pre-configured and you can adjust the pre-configured values according to your testing needs. Next is a bending test, in this case, a bending test of bone plates. Here in the middle, you can see a 4-point bending test fixture. On the right-hand side, you can see this 4-point bending test fixture is as well possible to be operated as a 3-point bending test fixture. We not just have these only with compression loading. If required, you can have the bending fixtures as well for alternating loads. And then the specimen itself is somehow fixed at the ends and moved in the middle as well through zero. So you can have tension and compression. You can see in this test, the frequency is up to 5 Hertz, and the test can be more than 1 million cycles. We even have customers for the biomedical testing that go up to 10 million cycles. So a high number of cycles, test cycles, is not an issue for these machine types. Next are again some examples for biomedical testing. So on the left-hand side, you can see some other spinal implants with the standards that they are tested against. In the middle, you can see hip protheses or hip implants. This can be tested with our testing machines as well. The tests, depending on the standards, require sometimes a 10 kilonewton machine, as some loadings are up to 5.5 or 5.6 kilonewton. But that's not an issue. We have these machine types, as explained before, from 1 to 10 kilonewton. On the right-hand side, you can see testing of dental implants. These machines normally are smaller. For dental implants, you normally just reach forces up to 1 kilonewton maximum. Displayed in the machine itself is a biomedical bar. So if required, you can test your dental implants or other test fixtures that you have to test in a saline solution, and this bath as well can be heated up to body temperature of 37 degrees. We can go up to about 40 degrees with this biomedical bath. If required, we have special bath as well that can go up to higher temperatures. But in this case, for biomedical testing, we only go to a biomedical bath to simulate the body temperature. Next, I want to show you some plastics testing or components made of plastic that we can test with our test machine. On the left-hand side, there is, we call it cracked round bar test. That's a test of a polyethylene round material. The specimen is normally 100 millimeter long with a diameter of 14 millimeters. You run it in a force range of typically 150 to 1500 Newton. The test is done until the specimen breaks, and then in the report you can see the cycles, how long the specimen took to break. It's done to ISO 18489. In the middle you can see a plastic gear, so that's just another example of how versatile the machine is or what test fixtures we have. It's not just a machine that we have. We as well have this test fixture to test, for instance, plastic gears. And on the right-hand side, you can see a 3-point bending test of composite materials. So even with your plastic testing, if required, we can support you. Next is a machine displayed with a temperature chamber and 2 different grips. So on the left-hand side with the red specimen, you can see our mechanical grips or T-fatigue grips, as we as well call them. In the middle between the grips and the machine, you can see our pneumatic wedge grips. Pneumatic wedge grips are mainly used for, let's say, softer specimen. As with these pneumatic wedge grips, you have the possibility of continuous gripping. So we have a pressure sensor inside, and the gripping can be adjusted with the software so that you can ensure that during the test, your specimen is always clamped. What's then possible with this test setup is testing or creating of SN curves for plastic specimen. This is more and more becoming popular as well for your plastic specimen. This test in the past was more done for metal specimen, but now SN curves are as well created for plastic specimen to have the material properties better for simulation available. So we have a software as well for optimized test frequency, because during the test of a plastic specimen, the temperature should not rise to a level that is no longer allowed. Normally, we allow from, depending on a standard, but for a plastic specimen, we roughly say from the starting temperature, which is in a lot of cases room temperature, plus maximum 5 degrees. So there should not be more temperature heated up the specimen. In case it's required, you as well can test these plastic specimen with a temperature chamber shown with the machine on the right-hand side of these 3 pictures. The SN curve is then created by the system. You have your different load levels, and the machine itself is creating a table, and out of this table, these load lines or the SN curve is then created so that you have your SN curve for your plastic specimen. Another test setup would be testing of plastic specimen or even rubber specimen according to DMA, so dynamic mechanical analysis. Here for these DMA tests, according to different standards, different results are requested by the standards. And you can see listed here what we are able to create as a result from our testing machine. So there is a designated test expert research software that allows you to create these DMA specific values with our testing machine. As before, some DMA standards require testing or testing under temperature. We have temperature chambers. We can do temperature ramps, everything that is required to test according to DMA standards. For all these values and what I show, we have as well on our homepage product information, and this is what you can read later even on our homepage and not just here in the presentation. As a special example for metal specimen and metal components, I show you here some test of a metal gear before we have seen the test on plastic gears. Here we have a test with our LTM on metal gears. You see in this case the test was up to 3.5 kilonewton. So the test was done with a LTM5 frequency of 20 hertz. And it's not just that you can test this specimen. This is, as an example, the possibility you can test flat specimen and other metal specimen that you can think of as well in this testing machine. Here are some examples for automotive testing. So on the right-hand side, left-hand side, we have a compensator for an exhaust system for cars. This can be tested with our testing machine. In this case, as you can see on the left picture, with a safety device to protect the operator if the specimen itself breaks. And on the right-hand side, we have a testing machine that is displayed with testing of a engine mount. So it's a rubber metal component. So this just should show it's not just related to one material, you as well can test material combinations according to what is required from your side. The left-hand side as well shows the use of our T-slotted table so that the fixture itself can be mounted on a T-slotted table. If required, you can even have bigger specimen or bigger components mounted to your T-slotted table. In this case, I want to show you as an example test of electronics or electronic components. Here in the middle you can see the test of a fuse, and on the right hand side displayed the size of the machine. Therefore, a woman is standing next to the machine that you can see the size of the machine itself. As we have said, as I said before, the machine is pretty compact with a small footprint. It can be as well low in height. And that's just an example of what can be done with electronics. We as well tested in the past the switches of a mouse. We tested electronic boards. We tested wire connections. And this test, as displayed here, of a fuse is just an example of electric or electronic components that can be done. Next slide shows some tests on batteries or battery cells. With all the electric mobility, these tests are more and more important. On the left-hand side, you can see a battery cell itself where a connection is welded to, and this connection can be tested with our machine. In this case, the customer tests this specimen as well in a temperature chamber. In the middle, you can see the connections of a more or less battery cell itself. It's a flat one. And here the specimen is gripped at the bottom and at the top to simulate some loading during installation or during operation, that the contact points for these load cells are tested. And here to finalize the overview of our LTM, I show you what we did in regard to customization. In this case, the customer is testing some metal ropes or metal cords. And this test device that you see here is especially designed together with the customer to fulfill the testing requirements. We have, as you can see on the left-hand side, safety housing, not just for the machine itself. So the whole test itself is protected. So the test device is even inside the safety housing. So we designed this as it is somehow delivered in the automotive industry, and we have to protect everything for misuse, and we have to protect the users, the other users. So we do complete customization of the testing machine. So in this case, we just used a basic testing machine and modified it to the customer needs. This as an example, what can be done for tests. Thank you. Bye.